Good morning everyone. Today we will be discussing about symmetric compound pendulum experiment. We will be having a real lab uh, session today using Amrita Vidyalaya virtual labs. So the aim, apparatus, principle, procedure we'll be discussing here, and then we'll be using the VLabs to simulate and to see the experiment. So the aim is to determine the acceleration due to gravity at a place using symmetric compound pendulum. We need apparatus like compound bar pendulum, stopwatch, and a pointer, which we will be keeping in the knee so that we can uh, get the oscillations, number of oscillations. Basically, a compound bar pendulum consists of 1 meter long bar which has holes drilled in its length. The holes are equidistant and the pendulum will be suspended on a knife edge. So this is the apparatus fitting for the symmetric compound pendulum. So here we can see that there is a small knife edge, and we will be suspending the compound pendulum on the knife edge, and we will be oscillating this compound pendulum. The principle is like this, that if L is the length of the equivalent simple compound pendulum with time period T, then we know T is equal to 2 pi root of L by G, and from this equation we will be getting G as 4 pi square L by T square, where G is the acceleration due to gravity at a place. L is the length of equivalent simple pendulum. We will be discussing how to get the equivalent simple pendulum length of equivalent simple pendulum, and then we will be discussing how to get the time period of the simple pendulum. So let's see the procedure. Procedure is, now let's consider the pendulum is, the bar pendulum is hanging on the knife edge, and let's oscillate the pendulum. We will be noting the time for turn to oscillation, and we will be repeating the procedure for different distance, and repeating the number of times so that we will be able to get a better result, and we will be calculating the average time and time period using this. Now we will be drawing a graph taking period in y-axis and distance in x-axis. The graph will be having two branches. The center of gravity of the bar pendulum will be determined by balancing on a knife edge, and the distance of center of gravity from the end A will be measured. A line perpendicular to the x-axis is drawn. Here MN shows the line drawn from the x-axis, the center of gravity, representing the center of gravity. Now another line is drawn from parallel to the x-axis from y. This line cuts A, B, C, D on the two curves. Then the radius of gyration could be calculated as root of AG into GC, and also length of the equivalent pendulum can be calculated using AC plus BD by 2. So these are the two methods, and also you can get the radius of gyration taking the minimum points of E and F of the two curves, and EF will be 2K, or K will be EF by 2. This is how we will be able to get the radius of gyration. When we get the radius of gyration, we will be able to calculate the moment of inertia, as the moment of inertia I will be, if m is the mass of the pendulum and k is the radius of gyration, then moment of inertia will be mk square. M is the mass of the pendulum, and k is the radius of gyration. With this, let's go and see how to simulate. I have created an account in virtual labs Amrita. So just like we have discussed the theory, here you can see the time period and distance, and they have taken the center of gravity and they have drawn a line parallel to the x-axis and also a parallel to the y, uh, the parallel to the x-axis and the parallel to the y-axis, and the time period. The line from the period cuts in A, B, C, D as we have discussed, and uh, here we can see the bar pendulum with equidistant hole, 1 meter long pendulum. So let's go to the simulator. Okay, here we do have a stopwatch. Here the symmetric compound pendulum is been suspended on a knife edge, as you can see, and we need to measure the distance, the number of oscillation. We need to find the time for an oscillation, and then we need to find the time period. From this one we will be calculating, we will be drawing a graph just like we have already discussed, and we will be calculating the length of equivalent pendulum, and from that one we will be calculating the acceleration due to gravity. So let's start the experiment. We are just oscillating. Now once the pendulum comes to any of the extreme positions, we will start our count. Let's take the leftmost position in the next oscillation. 0, 1, 2, 3. Okay, now let's start the stopwatch. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, you can see it is 30.9. So we will write, say, let's take the distance as 5. Number of oscillation is 20. Now we got 30.9. So let's write it as 31. Again, let's do the same experiment. So this time let's start from left. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so it is almost 31. So let's enter 31 here and we will get a time period of 1.55. So when you do the experiment repeating for 10, say let's take 20, let's take 30, 30 or 30, then for other one 15, let's consider 20, 29, 29. Okay, so it will decrease and we will be completing all the distance up to 90 or 100. Note that we will be having center of mass and okay, here now once we got the whole reading, we will be taking the length from, we will be calculating the length from the graph will be AC and BD. So let's think that the AC will be 60 and BD will be 56 and period will be 1.6. So with that values we almost got 8.9. So let's say here if it's 60 to 62 3, we will be getting almost 9.7, 9.8. So this is how we will be simulating the graph. I hope you understood the concept behind or the practical experiment behind simple compound pendulum or symmetric compound pendulum. Thank you.